Okay. Good morning. I think we're streaming again. Today we're not going to make huge changes. Today I think we're just going to add in the checks, get ready to make the regularization term a constraint rather than a term in the objective function, and that's all we're going to do. If we get that far. Okay. So here's, let's make sure, I did want to make sure that I checked in those changes that we've been working on. Okay. They're checked in. So what we're moving to is the following problem. Minimize where's lambda? It's a parameter that starts out as 0. Now here, the question is, should we, there's a question with sigma. What's the question? Right now, sigma is set. So it's the L2 norm of all the data in K-space across all coils. So firstly, perhaps we should have a different sigma for each coil. That's a generalization of this optimization problem that I've put here. And maybe we'll do that, but we'll do that later. Secondly, maybe sigma should be a value such that if n were the number of pixels across all coils, then we would multiply sigma by n. I just don't know. We're going to leave it as sigma for now. So this is what we're working towards. We want to be able to solve this problem. But we're going to start by adding checks in for the adjoints. So let's add that parameter value. Like before in MRI Recon SPIRiT, I'm not going to, put do checks in the usage. It's just a parameter that's going to be like a hidden parameter that you and I can use and anyone who reads the code can use, but if we're not going to advertise it. I don't know. I don't know how I went down to the bottom of the page all of a sudden. Character vector is not terminated properly. It's early in the morning, folks. Early in the morning. Too many input arguments. Is this a thing? Okay, that seems to be an actual character array. There we go. Oh boy. Well, we've added some code that we will check in at some point. We've got two checks here. Let's do some checks. Now you might say, why are we doing these checks? Didn't we see that it was working last time? Well, we saw that it gave a good result, but as we've already seen during these set of streams, you could get a good result even though the code's not really working, which is scary. So one thing is that do checks is going to help us, it's just a nice thing to do. It takes almost no computation to do the checks. Since we're turning when we're not using it, we turn it off. It's just one if statement. It's nice to have, builds confidence it builds my confidence in this code, my code. And then also we're going to be, altering this code substantially. And so when we do that, we're going to want to make sure that these checks are set up and that as we alter the code, the checks keep running and that things keep checking out. That's why we're doing it. Before we do that, I realized last night I want to do, this, what I'm about to do now, is closer to what the code is actually doing. The FS is outside here. So that's, this problem is equivalent to this one, and this one that's highlighted now is actually what the code is doing because we have broken this FS out of this block matrix, and it's really this block matrix now that's A, I think. Nope. This is still in A. So A is the block matrix with the FS, and then this is A top, and this is A bottom. So that's good. The square root of lambda out here makes it seem like we're multiplying the entire block matrix. When we're not really doing that, we're just multiplying what's on the inside. So that's better still. On the inside, on the bottom, we're just multiplying the term on the inside that's on the bottom. So square roots are actually surprisingly expensive. Might as well just calculate it once, store it in memory, and then never do that again. All right. You might say, why not just have people pass in square root of lambda instead of lambda? We could do that. These are, super fast computers. We're used to thinking about the regularization parameter as lambda, so that's what we're going to do. Okay. Back to do checks. So we've got do check for W. Do we have an SK data? I forget. No. Okay. What does A accept? A accepts S, which is size image. Does do checks work? That passes, that crashes. Failed. Looks like we've got a bug, doesn't it? All right. Okay, A top passes. Let's check A bottom. What we're doing here, of course, what we're doing here is checking whether the individual parts of A pass. And this is going to help us figure out where in this code the error is. I expected A top to pass. It's really a small amount of code, right? It's just the sample mask. Doing that in Vim is very nice because you could just say find and replace anywhere you see a pattern on a specific set of lines. So that would have been very much easier in Vim. Adjoint of bottom failed because square root of lambda is not in both. Still fails? A significant error, okay. W passes. Right? W passes. A bottom is this matrix, square root of lambda times W minus I. A bottom is equal to square root of lambda times W minus I. Let's take the adjoint of all of that. W minus I adjoint times square root of lambda adjoint. Square root of lambda is a scalar. So a number is its own transpose. The transpose of I is itself. I is an easy matrix. I mean, it's just symmetric, okay? So if out is equal to square root of lambda times, if out is equal to this, times in, then AB transpose times in should be this. And we already know that it applied W passes, so the problem should not be here. Well, that's a Mind bender. Huh. That's strange. Same error. Lambda's small, right? Lambda's 1 times 10 to the minus 3. Oh, it's not that small because it's square root of lambda. Okay. Let's make sure. The issue is not with the square root of lambda. I'm just checking if the adjoint of A bottom without lambda is correct. Nope, still fails. So it has nothing to do with lambda. Let's keep going. Now, if I take away the minus in, this is just apply W. Which is already checked. Let's see if that passes. This should pass, right? It fails? How's that possible? A bottom now is just apply W, right? That is surprising. Wow, it never got to apply W. It only did the adjoint. What on earth is happening? I have no idea right now, but it looks like the issue is going to be somewhere in here. Why didn't it ever get to an A bottom? Where is A bottom? Oh, I'm in SPIRiT. In A bottom, it never once hits. It never once does the no transpose operation. No TRA and SP. No TRA and SP. Where's the F? F should be A bottom. no transpose. So here, I believe it should go into the no transpose operation. And R in is 2, and up is no transpose. Logical 0. Oh my gosh. Did you guys see that space? That space right there was what was causing the issue. All right, let's see if that passes now. Yeah. Let's see if A passes now. Yeah, okay, great. Here's a question. Was that actually in the code? Did we commit that, or did I introduce that space sometime recently? Nope, it was there since yesterday. Okay. How did this work at all? That's why we do checks. How on earth did this work at all? Is there some mathematical equivalence thing that I don't see? And that's how all of this works? Even when I totally mess it up? Like, is A bottom symmetric? No, if it were symmetric, then the adjoint check would have passed. And it's not symmetric because W is not symmetric. How on earth did this work at all? Hopefully the image is as good. Nope. That image is pretty bad, isn't it? Let's pass in a lambda of 0. So that should just be model-based reconstruction. This is a code that just does model-based reconstruction. it should be doing the same. So apparently we don't have a usage for this thing, so let's add that. Not enough input arguments. All right, we got the usage. Great. Oh, that's interesting. I set it up so you could pass in the support. If you're interested about that, I have these conference papers on non-rectangular fields of view. It's presented here. Okay, so, but we're not doing that today. So that would be fun for a future thing. So now what I'm going to do, I'm going to ask model-based reconstruction to give me back an image. I'm going to ask this new SPIRiT reg with a lambda equals 0, which includes no regularization, to give me an image, and then I'm going to show them both, and we're going to see if they look the same or not. LSQR function failed. The logical indices contain a true value outside of the array bounds. There's a problem when you rely on codes that have bugs on them, isn't there? Let's do checks. What happens if you don't pass in the sensitivity maps? Huh. What happens if you don't pass in the sensitivity maps? That's the bug. That is the bug right there. We've got multiple coils of data. We're doing model-based reconstruction, but we're not passing in sensitivity maps, and that's the issue. So I think there needs to be a check. I think there needs to be a check to ensure that if you're passing in multiple coils of data, then you're also passing in sensitivity maps. Why would you do a model-based reconstruction without sensitivity maps? What does that even mean? Well, it's because of this support. You could do a model-based reconstruction, which is solving this problem. And not have sensitivity maps, which is just assume that sensitivity map is I with a single coil when D, where D is the support matrix. So if n coils is greater than 1 and the number of sensitivity maps is 0, then that's an error. You must pass in S maps when n coils is greater than 1. I think that's going to be the issue. Yeah. Now this QR runs just fine. Right, so that was the issue. Okay. Let's see if these images look similar. They don't. These two codes are supposed to be doing the same thing, and they're not. This is outputting something good, and this is outputting something bad. And the adjoints pass. One way to solve this would be to launch 2 instances of MATLAB and step through this code one step at a time, making sure that each line produces the same thing. And that's maybe what we're going to have to do. D here is what? That's the sample mask. Let's make this M, since D is the support matrix on the other. Code. Okay, all the do checks pass. Succeeded. Right. Let's just see if we can figure this out. I mean, like before, there's only two places where this could be a problem. There are only two places where there could be a problem. B and apply A. This should be Y. I don't know why I called that Y anymore. Why did I call that Y? Because there's this A up here for finding W? I don't know. Maybe so. Yeah, because there's going to, oh, that's why. Oh my goodness. Let's call this B. Oh no, because I'm calling this block matrix here B. But I can't call this Y. I'm going to call it B. Now I need to make sure that this is Y. Is that the issue? I would think not. B compound. Well, is it too much of an abusive notation to call this thing B when I was calling this B earlier? We're just going to go with B for now. Maybe the thing to do, yeah, that wasn't the issue, is to break out this into its own function so that there's no more of these conflicting names in scope. And it wouldn't be unreasonable to break it out into its own function if indeed we're going to use it for both recon spirit reg and recon spirit. Right now we're going to put it in this code here. Looks like it's going to take the auto calibration region. And W size and coils equals size ACR 3. Is that all we need? Let's see if that works. Not enough input arguments. Why not? Oh. SACR. Looks like we found W. Okay. Now I can make this B as was always intended. We're solving AX equals B here, or actually AW coil equals B. As long as we're doing this, you make progress when you can, where you can. W takes almost half a second. Oh. I forgot how to make a cell array. I think it's just cell. All right. Maybe I parallelized that. Saying these two are broadcast variables. Okay. So maybe I just parallelize this and maybe it runs a tiny bit faster. Let's find out. Takes a third of a second. So we shaved off 0.15 seconds. Why not? Okay. We still got TikTok? Let's see. Whoa! It was because of the matrix allocation. I was still allocating the zeros for the matrix W. So it went from almost a half a second to under a tenth of a second. Like I say, why not? Matrix allocation is expensive. Didn't fix anything. Here we have B. In the future, if lambda were 0, the right thing to do is just call recon model based. So we don't have to do these calculations at all. Like, why are we multiplying W times anything if we're just going to multiply by 0 afterwards? For now, we can make sure that A bottom in is 0. It's not. What is lambda? Lambda is 0. Square root of lambda should be 0. So out should always, always, always be 0. Oh. That should have been distributed. Is that the problem? It's running longer now. Look at that. That looks pretty good. Okay. What was lambda before? 1 times 10 to the minus 3. Now the adjoint operation fails. The adjoint operation of A bottom failed, right? All right. Let's say lambda's 1. Then does it fail? Yes. Let's do the thing again that we did. We're going to get rid of one term at a time and see. Let's see if this passes. Now, from what we just saw, it shouldn't. Right. Oh my gosh. How did that space show up there again? Okay. That doesn't so the regularization there doesn't seem to be having much of an effect. I think we've solved bugs. Certainly the checks are passing now. Let's increase the regularization by a factor of 1,000 and see what happens. That's cleaner, isn't it? This is working. Okay. I want to run another test, and then we'll be done for today. I want a different undersampling pattern. We undersample, so this is only 25% of the data now. We're undersampling horizontally and vertically. Wow. That's with only 25% of the data. That's, well, 25, more than 25% because of the auto calibration region. That is a very good result. So if we compare that to model-based reconstruction, starting to get ready to check in this code. Checking to see if there's anything in the first column here. There doesn't seem to be. And let's not forget, we've made it more efficient by parallelizing here. So that's, incredible. I'm wondering if I can make this more efficient, which we'll think about in a second. Right now I want to compare the the results of model-based reconstruction to those with spirit regularization. Should have titled these. So this is spirit regularization. This is model-based reconstruction. Those look very similar. I'm astounded at how well model-based reconstruction is doing right now. I mean, how much do I need to undersample? Okay, that's model-based reconstruction in the log scale. Let's do the same thing for spirit reg. Okay. A slight difference. We seem to have beaten down the noise a bit, but not much more than that. What's the size of the auto calibration region? The size of the ACR is too small for this kernel. This kernel is 5 by 5, okay. 19. There's this weird phenomenon. We're solving for coefficients for every coil. So the more the number of coils, the larger our linear system, which means, or the more the number of coils, the more variables we have, which means the larger we need to make our linear system in order to make sure the system is overdetermined. But that's weird because more coils is more information. You would think you'd need less information, less data to reconstruct a high quality image with more information. I still struggle to wrap my head around that one. Okay, this is with a dramatically reduced auto calibration region, not dramatically, 31 to 19 or something. Spirit reg is on the right, MBR is on the left. Can you tell the difference? I can't. Oh yeah, look, you see these little sparks of noise over here? See this? It's gone here. That's something. That's something meaningful. If this little spark, we're inside the ankle, and assuredly it is. It's not. We're seeing it because the contrast is higher in the noise region, but this is the magnitude of error, presumably, that's inside the ankle. And if it were inside the ankle, and someone were paying really close attention to a particular place in the anatomy, maybe that makes a difference. I don't really know. Okay, what if we sent this to 100, 1,000 even? What happens? Do I have... Okay, I've got an entire paper on arXiv describing the non-rectangular field of view thing. This is the support matrix. The idea is that, the field of view in MRIs is a rectangle, and it must encompass the entire object. But if you could draw a non-rectangle as the field of view, then that would encompass less area, and you would need less data. You should need less data to reconstruct a high-quality image in this light gray region than you would need in the dark gray and the light gray region. And indeed, I found a way to reduce the amount of data required and still reconstruct a high-quality image. So here's an example. Here's fully sampled. Here's with 25% less sample, and the difference is not much. Okay. So this is what happens when we set the regularization parameter too high. I knew it would break. That's fine. It broke. Great. It breaks in an interesting way. I've never seen something break like that. Okay, so we now have a slight improvement when we compare it to just regular parallel imaging, model-based reconstruction. Okay, so before we go, I had asked this question. Let me check what I got going on today. I need to get going. Okay. I'm wondering if instead of this, can I just do this? Are those two codes the same? I think they might be. Let's see if it gives us the same image. Oh. Okay. The issue is that cert column 2 assumes you have the same number of dimensions in both the kernel and in both the first argument and the second argument. Right? But if I do this, no, that's wrong. I wonder if it works then. Arrays have incompatible sizes. Looks like it doesn't. Something to pursue at a different day. Apparently, we're not doing that today. So a to-do item is to make cert column 2 work when A and K have different numbers of dimensions. Okay. Let's go through and check all this stuff in. What did I... Oh, we fixed the bug here. In a sense, we added usage and we added this check to make sure that if you're passing in multiple coils, then you're passing in sensitivity maps. Added usage, made W more efficient, fixed a bottom, added checks. Yep. Okay, so the only change that I saw, we don't want this anymore. And this is not yet. Huh? In run recon SPIRiT Reg, we change the size of the auto calibration region, change the undersampling mask, and it still works. Model-based reconstruction works very well here, and SPIRiT regularization works well. Okay. Okay. This is what we're going to do next time. This to do. We've already got in the usage, but not in the... not in the parameter list. So today was an exciting day. We've now compared our new algorithm to model-based reconstruction, and we see that the new regularization term does indeed help. It improves the quality, and that's wonderful. We're on our way to having created a whole new way to accelerate MRI, which is really exciting, I think. Thanks for stopping by. See you on the next stream.